Hello everyone, my name is Mo. In this demo video, I will compare the performance of TCP and PCC under identical network conditions. So to do that, we provision two experiments on MLab, which each experiment is basically one sender and one receiver link with a software bridge sitting between to be allowed to take all the bandwidth latency, loss rate, and bottleneck buffer size of the network on the fly as we run the experiment. So we provision two pairs of these identical links. So one PCC flow and one TCP flow are running perfectly isolated with each other, but are experiencing the identical network condition because we tweak the network parameters concurrently for this software bridge for both of the link. So let's go to the demo. This text editor is actually our UI. We can see that currently the network condition is pretty nice. It's a 30 millisecond RTT link with a 30 megabit per second bandwidth, and the bottleneck buffer size is 75 kilobytes. There's no loss rate. It's clear sky. And the TCP protocol we are comparing against in this setting is TCP cubic. Now let's start the experiment. Now what this script will do is it will live stream the running data comparing TCP and PCC performance to my local machine. As you can see that under this network condition, PCC and TCP are doing pretty similarly with each other, while PCC is like 15% higher throughput than TCP, but it's not a lot. Now let's change the available bandwidth to be a higher value, say 150 megabit per second. Because I'm running on a laptop with pretty non-reliable wireless connection, so it may take a while to let my local configuration here to propagate to MLab. Oh, here we go. So we can see that PCC rapidly ramps up and grabs the available bandwidth here. It's operating very near the optimal. Let me expand this window a little bit. It's operating very close to the optimal. And now it is actually 4 times or approximately 5 times higher throughput than TCP. Now let's increase the RTT a little bit. It makes it look like West Coast to East Coast link or cross-continental link. We can see that PCC is not actually affected by this increase of RTT, but TCP, as we soon will see, the throughput drops basically. And let's treat TCP a little bit nicer to give it a higher buffer size. As you can see that this is a 20. PCC is now doing 20%. Oh, now 12% higher throughput than TCP, with the increased even with the increased buffer size. Now let's change everything back to normal. Okay. Now let's add a little bit drama here. Let's add, say, 0.3% loss rate to the network, which is a very tiny loss rate. And let's see how TCP and PCC performs. We can see how TCP's performance collapses under this scenario, even with a very large buffer. And let's make things even more interesting by adding up the RTT a little bit to emulate a satellite-like network, which you will experience actually in the in-flight Wi-Fi today. You can see that PCC is basically not affected by this increase of RTT and added loss rate, but at the same time, TCP really collapsed, and now PCC is definitely 20 times higher throughput than TCP. We can even increase the rate a little bit for PCC, which PCC is basically not affected very much. And let's again change everything back to normal and remove the loss rate. No, okay, this is too short latency. Okay, now TCP also ramps up. Let's take another interesting thing. Let's change the buffer size to be a very small buffer. We can see how TCP jumps off the cliff with a very small buffer, while the PCC is basically completely not affected by this reduced alpha buffer. Now let's stop this experiment and say I want now change the protocol comparing with PCC as TCP Illinois, and let's say change this. Something random, and restart the experiment. Now we can see that under this network condition, and when using TCP Illinois instead of TCP cubic, PCC is actually doing 1 magnitude higher, achieving 1 magnitude higher throughput than TCP Illinois can achieve. You can actually play with this demo software the way you want, changing bandwidth, RTT buffer size, loss rate, or the favorite flavor of TCP you like, and evaluate their performance. Thank you for watching.